All right. Hello, everyone. My name is Joshua Lambert, and I'm a product manager here at GitLab. And we'll be going through today and taking a deep dive look at GitLab CI. We're doing this live on YouTube, so if you have a chance and are watching this live, please hop on and take a look and provide feedback and comments here in the chat, and we'll try to address these as we go along. And we'll also have some time at the end here to do some Q&A as well. So let's get started. We're going to try and cover off three things today. The first is installation of GitLab, and we'll do this from scratch on Kubernetes. We've chosen Kubernetes because that's where a lot of our forward-looking roadmap is and where we're building features, and also where we see a lot of our customers moving to as well. Next up, we'll give everyone a tour of the complete end-to-end developer experience that GitLab can provide. So in other words, how we here at GitLab think the developer experience should be. And we'll do that by following a relatively simple project all the way from concept to delivering that to your customers and then making some improvements. Last, we'll go into a deep dive of GitLab CI and give everyone a look at how flexible, scalable, and how self-service CI can be here with GitLab. So let's get started and talk a little bit more about the installation we'll be going through today. We'll be taking advantage of GitLab's official Helm charts. And this is because it's the fastest and easiest way to deploy GitLab on Kubernetes. Helm is essentially a package manager for Kubernetes, which makes it easy to install, update, and just in general maintain your software running there. Our chart includes, of course, GitLab itself, and that's using the GitLab official Docker container. And inside of that, of course, is again our GitLab services, but also our container registry, Mattermost, an open source Slack alternative, and Prometheus, an open source monitoring solution. We'll also go ahead and deploy the GitLab runner, which is also part of our chart, and then some dependencies that were required to run, things like Redis, Postgres, Nginx, and Let's Encrypt for instant SSL. We'll be going through and again using Kubernetes here. And to do that, I've gone ahead and set up a few things ahead of time just in the interest of time. So I've gone ahead and provisioned a static IP address. I have mapped a DNS name to that static IP. And we've also gone ahead and created a fresh, brand new Kubernetes cluster in GKE. So that's it. Let's go ahead and get started with our installation. So to do that, we'll pull up our trusty console here. And the first thing we'll do is take advantage of our Enterprise Edition here. So we're taking advantage of Enterprise Edition, has all the best features of GitLab. If you haven't tried it, definitely give it a shot. But we've gone ahead and done a simple registration, which you can do online through our website. So you can simply go ahead and go to about.gitlab.com, click on our products, for example, and then any of the options up here, you can essentially either buy or start a free trial. And when you do that, we'll go ahead and shoot you an email with your license, and you can simply download it from here. And in this case, I already have a license for myself, so I'm going to go ahead and simply use that downloaded on this system. So what we'll do is go ahead and copy that license into an environment variable so we can use it going forward. We will then add the official GitLab chart repository to Helm. Next, we will initialize Helm. And what this does is it provisions the sort of software management components or tiller over in our Kubernetes cluster, so we can then go ahead and begin to actually install our software. So let's go ahead and do that now. And we'll take advantage of our all-in-one chart. We do have separate charts for GitLab on a runner, but the easiest way to get started is using our all-in-one chart, as you can see here. And we only have to pass just a couple things. The base domain name, the base IP address. In this case, the fact that we want the enterprise edition, and then our enterprise edition license. And then finally, since we're using Let's Encrypt, our Let's Encrypt email. And that's it. We can go ahead and install our software. This will take just a couple seconds here to complete, and you can see we've gone ahead and provisioned our dependencies, and we have also have a variety of our services coming up online here. So let's go ahead and take a look at this. We can now run kubectl proxy to connect to our instance or our Kubernetes cluster, and we can then browse to the Kubernetes dashboard to see how things are looking. So let's go take a look at our GitLab instance, our GitLab namespace, and you can see we have our deployments just starting to come up here now. Now you'll see these errors here just because the storage that is required by them, the persistent value claims, haven't been fully provisioned. And so it can take a little bit of time for those PVCs to come online. And then once they are, the pods will then also continue to start and move forward. And so that's actually sort of an expected error message here as we're deploying everything here at once, all of our storage requirements, all of our services like GitLab and Postgres and Redis. And again, it'll take just a minute or two here for these to go ahead and start. And as you can see here, they're now starting to go green. So that's great. We now have our Redis cluster and our Postgres database up and running. And very shortly here, our GitLab server will also come online. It does take a little bit of time because the error message will persist until Kubernetes can actually verify that the health check URL is operational. And so that does wait for GitLab to sort of start, connect out to the database, connect to Redis, reconfigure itself with the configuration options that we passed in through the chart. And so it can take a little bit of time. And if you'd like, we can also look at that live here. So we can go take a look at our pod, which as you can see is running, but hasn't yet completely started up. And you can see the familiar sort of, if you're familiar with GitLab, the familiar startup sequence here of our reconfigure process. And that isn't actually what's happening here because our Docker container, our Docker container is in fact based on our official Omnibus image. So take just a couple seconds here to reconfigure and get started. But I did want to show everyone here sort of the complete installation process from the very, very beginning all the way to, again, delivering some value to customers in the production environment. So you can take a look at our logs here, see how they're progressing. Looks like we're still in the configure process of GitLab. So you can take just a couple seconds as we go ahead and make sure everything is set correctly with the variables that we passed in. And take just a couple seconds here to complete. And as you can see, it looks like our instance is now should be getting pretty close to operational. It's now accepting a web request here, as you can see, and the health checks are now passing. So let's take a look and see if we can connect. And we can. So I will very quickly enter in our new root password. And that is essentially setting the password for the admin account of our instance. And next up, though, we want to register as a new user because we want the developer experience, not the administrator experience. So let's go ahead and sign up for that now. All right. So as you can see, we've now gone ahead and signed in, and we now have our operational server, which is fantastic. So let's go ahead and create our first group. We want to, of course, collaborate with our team and begin to work together. And so a group is the best way to do that. So we'll call this one my group. We'll make it public. And then we'll create also a Mattermost team associated with this as well. That way we can all go ahead and chat together and have an easy place to collaborate. We'll make a new project here. We'll simply call it Ruby because we're going to be using a very simple Ruby project as our example. And to save us some time and not to watch me type a whole bunch, I'll import from one of our example repositories. Now, while that repository is going ahead and importing, let's go ahead and finish our configuration of Mattermost. And we want to turn on our Mattermost slash commands. And doing that is really quite simple. We can simply click on the Add to Mattermost button. You can see it's auto-populated our team. Click on Install, and click on Save Changes. And that's really all we have to do to go ahead and provision Mattermost configuration for my group. Next up, we'll configure CI. And to do that, we'll go ahead and leverage our Kubernetes template, which makes it really easy to get started because all we have to do is simply enter in our base domain name here, and the template takes care of the rest. If you didn't notice, we also have a wealth of other templates available here to help get started for other situations. Now, we'll commit this to master because we want our pipeline to run right now. We'll go back to our main project, and you can see this little blue icon here now indicating that we have a pipeline that is now running. This indicator will show you the current status of the last pipeline to run on master, so you always have a sense of how that's looking. Let's take a look at this now. So we have 4 stages. We have our build stage, which will go ahead and take our Docker file, which we specified in the repository, if you saw that, and simply build our Docker image. In this case, we're going to leverage our Ruby base image. We're going to add our Ruby code to that image, and then simply repackage it and ship it off to the integrated container registry. Next, we'll leverage that image that we just built and go ahead and deploy it out to our Kubernetes cluster. And you can see that happening right here. We're creating a namespace, the secret, the service, the deployment, and the pod, and those are now rolling out, and they just finished. And so we now have our staging environment up and running. So that's fantastic. Let's head back to our pipeline here and just completely deploy to production. That way we have an initial version of our site that's ready to service our customers. And this will take just a couple seconds here to complete, just like staging did a few seconds ago. Now, while that's going on, let's go ahead and connect to our Mattermost server, which also just got spun up, and start collaborating with our team. We'll sign in with our GitLab credentials, and we're now into Mattermost. So let's give our new slash command a try. As you can see, before I can use my slash command, I first have to connect my account in Mattermost with my GitLab account. So I will authorize that to happen. And now I can go back and successfully operate our slash commands. You can see we can work with issues, and we can also work with deployments. Let's go ahead and open our first issue, which should be improve our homepage, because our homepage is really hello world, which we can, of course, improve. Now, chat is important because these days, a lot of the innovation and the kind of collaboration happens in chat as opposed to in issues, especially for like kind of the ideation and concepts and kind of bantering back and forth around new ideas. And so it's important to be able to capture these easily and quickly and move them into issues for later prioritization and for later safekeeping to make sure they don't get lost. So let's go ahead and take a look at this issue right here. Great, so we have our first issue. And let's go ahead and plan to get for release. So I'm a team lead, so I'm gonna go ahead and go to our issue boards. GitLab issue boards are a really easy way to work and prioritize things for your team. And they're very, very flexible as well. And so you can see you have complete control over the columns that appear. And I can even have separate issue boards for each development team that my team has or my group has. Now, for me, the default lists here are perfect, to do and doing. So I'll just go ahead and leverage these. And I can simply drag our issue over from the backlog into doing, because we're going to go ahead and get started on this right now. So heading back to our project, let's pop open our server.rb file, which contains our relatively simple code here. We'll just simply make some minor improvements and save this back to a new branch. Now, I entered number 1 in front of the branch name, and what that tells GitLab is that this branch and this now merge request are now associated with that issue number 1. And so you can see GitLab has gone ahead and actually added closes number 1 automatically for me to my merge request. And what that does is that when this issue or when this merge request is approved and merged, will automatically tidy up and close the corresponding issue. So that looks great. We'll go ahead and submit this merge request. And you can see we have a new pipeline that is running. Let's take a look at this now. So we have our build stage, which just passed, and that again is rebuilding that Docker container with our new updated code. And we also have what's called a review environment now running. This is a temporary environment that is created for this particular merge request that essentially has a production-like instance running that we can use to preview our code. And that's important because looking at the code and doing code review is helpful, and of course everyone should do it. But actually getting a sense of what this looks like and behaves like, again, in a production-like environment is also critical as well, and arguably more important than the code review itself. And this gives you a really easy way to go ahead and do that, that not only gets started immediately upon the first commit, but also stays up to date as anyone makes further changes to this branch. So let's go ahead and head back to our merge request. And you can see that we now have added the fact that this is actually running on a review environment and have even provided a quick and easy link directly to this new running software. And so here we have our Hello Improved World. And so anyone collaborating with the developer, any other stakeholders can easily and quickly see that there's a place they can go ahead and check this out, perhaps UX or product or marketing, to get a sense of how this particular feature is coming along. So that is really transformative, and we think they're fantastic here at GitLab and make use of them in a variety of different ways. So that's our review environment. And you can see we confirmed it running here in production or in a production-like environment here, and it looks good. But what if there was a problem? What if it wasn't totally working correctly? Well, what we can do is actually do some live troubleshooting of this with our built-in web terminal. So I can simply click there, and I'm taken to a shell on the container that my software is running on. So you can see we can list the files, and we, sure enough, have our Docker file and our server.ruby. We can even go ahead and make changes or look at logs or do what we have to do to try and troubleshoot or figure out what's going on in this temporary environment. So here we go. We can make some changes. Restart our server and now open back up our environment, and you can see, sure enough, our changes have already taken effect. And so again, this is a really easy way to confirm and potentially debug some environments that are running without worrying about keys and things like that. So that is great. And this code, of course, looks good, right? So we've gone ahead, we've done our code review, and we have done our review of the application running in production. And again, normally you'd assign this out to another developer to review, but we can just do that here in the interest of time and say, you know what, this change looks good to me. Let's go ahead and merge this change into our master branch. Now, when we've done that, you can see we now have a new pipeline that's running. So let's go ahead and check this out. This is again running on our master branch. And so you can see we're back to build, staging, canary, and production, as opposed to our feature branch, which had that review stage in there. And we're going to go ahead and build our container and push our new container up to the integrated GitLab container registry. And that is really helpful, by the way, with the integration, because all the authentication is all integrated into GitLab CI. And so you don't have to worry about tokens and authentication. Essentially, as a job starts, we give that job a token, and that token is good for the lifetime of the job. And then once it's over, that token is no longer good. And so again, it's a really nice way to kind of have a secure, but still easy to work with a protected container registry. So that's great. As you saw, we have our deployment in staging, and now we're ready to go ahead and deploy into production. But maybe I don't really want to deploy all the way to production at once. Maybe I want to deploy to a more limited controlled release, perhaps do a Canary deployment. This way I can reduce the risk of my deployment and make sure it's running correctly before I turn it over to all my customers. Well, we actually have direct support for that within GitLab here as well. So I can go ahead and trigger the Canary stage. And what that will do is that will spin up a new node in production that is running this new version of our software. And after a couple seconds here, if I refresh our production environment, you will see that we'll have a new box with a yellow dot in it, which indicates that is our Canary pod. And so now we have 2 pods here servicing our customers. And if we go out and take a look at our page, we'll have a 50-50 chance of seeing the new updated software running, right? So in this case, we'll have half our customers getting the old stuff and half our customers getting the new stuff. And while this looks great here, from a customer standpoint, the next question would be, well, how's it performing in the environments, right? Is this new change having a negative impact on my CPU load, memory load, or other potential areas? And we actually have a really easy way to take a look at that as well here. So I can click on the monitoring button, and we'll actually give you a live look at the production environment and its associated deployments. And so in this case, you can see we have just a few minutes of data here. That's because this server just literally got started a couple minutes ago. But we also tag the deploys here as well. And so you can see in this case that right after this deploy, our CPU usage has started to creep up. This can be really important to take a look at, as if you have some funny results, you can actually trace that back to when a deploy happened, as that could potentially be a source of, again, some of the perhaps difference in performance behavior. And so these metrics are, again, great to have on our performance dashboard, but even better would be if we could actually take a look at this automatically and give you a sense of how the performance has changed over time here before and after the merge. And we actually do that as well. So if I go back to our merge request, you can see here we actually do show you the memory and impact of the change. In this case, you can see on staging, our memory usage went up, and the same thing happened on production here as well. And again, these are limited sets of data because we just literally got started, but we will capture, again, on the environment dashboard, 8 hours in the past, as well as here, half an hour before and half an hour in the future to get some average statistics on behavior. So that's really powerful ways to have some analytics and some idea of performance of your software and of your changes in production. Of course, trying to funnel that feedback back to your developers, because it's everyone's responsibility to make sure your software is stable and is performant. But we also provide statistics and analytics on the broader team itself. And we do this with cycle analytics. And what this does is it tries to give you a sense of how long it takes for your team to shepherd ideas from the initial stage of issue and planning all the way to delivery to production here. And this can be really powerful because it can give you a sense of not just how your team is performing, if you're perhaps at the manager or VP level, but also if there's room for places to improve. For example, maybe things are being stuck in the review stage for a while, and your team could perhaps do a better job and focus there and get things turned around more quickly to developers and perhaps unblock some of the previous sort of backlog that might be stuck here. And so again, it can give you some insight into perhaps ways to improve and to move more quickly and more efficiently in your organization. So now that's great. We went ahead and we deployed to our Canary environment with one node, right? And that's fantastic. But one thing we might want to do here is increase the number of nodes, right? So perhaps our performance of our CPU was perhaps not ideal, and we're going to increase the load, and we want to have a similar increase in our perhaps node size here as well. Well, we can do that here by leveraging our protected or secret variables. These are variables that you perhaps might not want to put in the repository, but in this case, it's just an easy way for us to set this in this case. But again, they're really great for things like credentials or otherwise secure tokens because they would not get actually imported or saved into the overall repository. And so we went ahead and we created a new variable called production replicas, and we set that to 10. And now if we go back and complete our deploy, so we hop back to our latest environment here, our production environment, and we now trigger a deploy to production, you'll see a couple of things. You'll see that we have our Canary node now be torn down, but in its place, we'll have an additional set of nodes to handle our perhaps increased demand or perhaps adapt to the changes in the behavior of our software. And so in just a couple seconds here, you'll see that the Canary will get shut down, and you can see we now have a full-on 10 pods waiting to be deployed. And these boxes here, as you can see, aren't just representations of whether your software is green or red. They're actually live looks at the behavior of each node in the environment. And so in this case, you actually see a live look at the deployment from pod 0 all the way scaling out to pod 10 here of how our software is performing, and each node as well, right? So you can see these are currently waiting, and then they'll turn a light green that they're deploying, and then they'll turn into a solid green once they're fully operational here. And so that'll take just a couple seconds to get fully green. So that's a great summary of, again, GitLab and the overall developer experience and flow from setting up your first server all the way through to deploying your code into production, right? And along the way, we leveraged chat ops, we leveraged review applications to get a temporary look at the code we're going to have in a production-like environment. We then leveraged canaries to deploy in a reduced risk fashion to a small portion of our user base. For example, right now with 10 nodes, if we did a new canary deploy, only 10% of our user base would actually see the changes. And so we can confirm this behaving properly before more widely deploying. And then, of course, we did a complete deploy of our updated software all the way back out to production. And we did that in right around 20 minutes because we had some extra voiceover here, and we waited for the full server to be up and running from installation. So pretty powerful stuff there. And again, this is how we kind of think the developer experience should be from, again, idea to delivering that to production. So with that overview, let's go ahead and change gears and take a look at a deeper dive of GitLab CI. And we'll do that with the help of a Java application, which we have over on this other server. Again, just in the interest of time here, we've got this project already set up and ready to go. Now, this Java application is made up of two components. We have our Java library, and then we have a front-end service, which utilizes the library to provide a simple hello to users who visit our website here. Let's take a look at our Java library. Now you can see, like earlier, we're leveraging the built-in repository features of GitLab because they're so integrated and because they're so they're pretty powerful. But actually, you don't have to use them. So if you wanted to leverage GitLab CI, you can actually connect it to any Git-based repository by simply setting up mirroring. And you can do that by checking this box here for mirroring the repository, and then providing the URL, and then simply checking the box to trigger pipeline updates, or try to trigger pipelines for all mirror updates. And that's it. You've now set up GitLab CI for any Git-based repository. Now, that is the code management side of things. But we also have integration with a variety of other agile planning tools. And again, a lot of folks use the GitLab built-in ones like you saw earlier, or issues or issue boards. But a fair number of folks also want to take advantage of software that they probably already have or might be making use of, things like Jira or Slack. And so we actually have configured those here in this product as well. So let's take a look at Jira and how easy it is to go ahead and configure. In this case, we simply provide the web URL. We've also provided our credentials to authenticate, and then we simply provide the project key and the transition to close issues. And that's all we have to do. Slack is also similarly easy as well here. We have both notifications and slash commands both configured. And in looking at how you do this, you simply go in, you specify what events you want to publish or push to Slack, and then provide the webhook. And that's it. In this case, we'll be pushing our pipeline events, and we'll do that for both successful and broken pipelines on all branches. And that's how easy it is to go ahead and integrate with Jira and Slack. Now, we also offer integration and pretty easy integration with a wide variety of other tools. These could be build tools like Maven or static analysis tools. And the way you integrate with those is is through your CI pipeline, and that's defined in what you saw earlier, which is the GitLab CI YAML file. Now, before we get too deep into that file, let's talk a little bit about how you work with that file and its properties. So as you can see here, it's actually checked into our repository. And that means that it has all the attendant benefits of being part of the repository. So it's fully versioned. So for example, if I wanted to test out some new changes, I can make a new branch, see the pipeline run, and make sure it's all working before perhaps merging it back into our master branch to realize those benefits or changes. But similarly, if I needed to jump back in time, perhaps we're doing a security update for a previous release, my pipeline is matching that same code base as it stands at that time, right? So I don't have a new pipeline definition running new tests or perhaps new commands with an older set of code base, because that might not work. And so these stay in lockstep, day and date, and versioned for every again, release you make, or every tag, and of course also all of your branches, which makes it really easy to work with. Now, editing the file and making changes to it is similarly easy because it's just another file in the repository. So nearly all popular IDEs these days have Git integration, which means you can use them to go ahead and work with your CI pipeline definition file. You also, of course, can leverage CLI tools as well, or our built-in web editor like you see here. Now, let's go ahead and take a closer look at our file and talk about some of its attributes and what these things mean. Up top here, we have a few sort of global defaults. We're specifying a default Docker image to use Maven. We're then specifying some variables. And then we're also setting up caching. Caching means that our runners will do their best to preserve these folders between CI job runs in the sense that they can help improve performance or build times for future jobs. Down below, we then specify the order of our stages. A pipeline is made up of one or more stages, and a stage is made up of one or more jobs. And so you can see the order is defined here for our stages. And then down below those, we then go ahead and define our jobs. Our first job, which is part of our first stage, is our build stage. And you can see here, we're simply leveraging that Maven Docker image to go ahead and kick off a Maven compile command. And you can see how easy it is to go ahead and do that. We simply kick off Maven, pass it our defined CLI options above, and say compile. And that's it. Maven goes off and compiles our code. Now, one thing you might look at and say that this looks an awful lot like perhaps the commands you type into your own command line tool or command line shell. And that's because it is. Our GitLab CI runners is based on, or the script is based on shell. And so anything that you can bash, anything that you typically do on your laptop, you can take those same commands and leverage them in the CI script. And it makes integrating with things like Maven or really any other tool as simple as it would be to work with those on your laptop as well. And you can have one command like you see here, or a complete list of commands, of course, as well with a longer set of a script. Further on down, we move on to our next stage, which is test. And in this case, we actually have two jobs that make up our test stage. You can see our first one is our unit tests, we will go ahead and again use the Maven to kick off our JUnit tests, as well as we'll also leverage the Cocoa to go and generate code coverage reports as well. Our next command will simply go ahead and extract and print the code coverage percentage directly out to the build log. And then down below, you can see we're also going to go ahead and leverage the GitLab built-in artifact repository to preserve our code coverage reports. And that way, if we want the detailed results, they'll always be there and attached to that job. And it's as simple as providing the folders you want to preserve, and the runner will go ahead and take care of the rest. The next job in our test stage is code climate. And so we want to go ahead and leverage some static analysis to confirm our code quality and see if we've introduced any new issues or perhaps have fixed some things. And you can see here we're going to go ahead and actually override the image we specified earlier, which was our Maven image. And that's because we want to leverage the Docker image, because we're going to use Docker and Docker to go ahead and kick off our code climate official container, pass it our code, run the analysis, and then retrieve the JSON output for further analysis. And you can see that persistence is as simple as, again, specifying it as an artifact. And that is as easy as it is to integrate with static analysis and to retrieve the results back out. A couple lines of script there, and you're on your way and done. So that's our test stage. We then move on to our documentation stage, where we simply generate our Java docs, persist those also as artifacts, and then move on to our publish stage, because at this point in time, we have validated that our tests are good. We've generated our docs, and so we're ready to go ahead and publish this out to our package cloud repository in this case. And now, if you remember, or perhaps are eagle-eyed, you'd recognize that this variable wasn't actually specified up top with our global variables. That's because this one we're leveraging those secret variables you saw earlier in our previous demonstration, where we set that production replicas value. And so again, this is a potentially sensitive token, and we don't want it output or perhaps published into our repository. And we can leverage that security at the project settings level, which is restricted to sort of project administrators. And then once we have that set up, we can then simply kick off Maven deploy and go from there. For our last stage, we're going to leverage two things here. Number one is GitLab Pages, which is an integrated static site hosting service. And so what we want to do is to leverage some of the technical documentation that we just created, our code coverage reports, our Java doc, and put them into one repository and then make them available to our to everyone really, and publish them out on a website. And we can make it really easy here with GitLab Pages, which is as simple as going ahead and saying that we want to utilize the artifacts that we saved earlier from these two jobs. We simply then copy the artifacts results from each of those into one single location, and then specify that as again, an artifact, and that will then get simply passed over to our GitLab Pages service, which then takes it from there and deploys it to the website. And that's as simple as publishing your documentation and your code coverage reports. The last stage is our trigger. And remember that our Java application is made up of two components. Our library, which is this file, or this project, and then our front-end service, which utilizes our library to go ahead and service our customers. Now, we've gone ahead and confirmed that our library passes all of our internal tests, which is great. But the real important test is to make sure that downstream projects aren't impacted as well, right? So even though these tests pass, we need to make sure that our front-end service tests pass as well, right, with the new updated library. And that is as simple as going ahead and kicking off our webhook for that other project, which you can see down below here. Also note that we're again leveraging the image. So we're using Alpine here instead of our default Maven image. And we'll also be adding some dependencies, which is as simple as using APK to add curl. And we then use curl again to go ahead and trigger that webhook. And that is as easy as it is to integrate with Maven, to kick off static analysis with code climate, perform unit tests, and then deploy to perhaps, in this case, package cloud, and kick off downstream projects. And that was all in under 100 lines of YAML code here. So pretty easy and pretty straightforward integrations there. Now, that isn't the kind of only limitation of our integrations, right? And that's kind of how we kick off, and that's how we work with these things. But we also have additional analysis and features to help surface these things as well, right? So our code coverage reports and our static analysis, those are great tools, and it's great that we're publishing them to our static site hosting service. But what about the reviewer, right? So when you're at a merge request and you're asked to review this person's code, this is a pretty important job, right? You're responsible for the overall code quality, and you also have all this other information available to you, again, like code coverage changes and your static analysis reports. And so GitLab, we try and make it easier for you, right? So you can see here we have our pipeline, which passed, which is fantastic. But we also here have our code coverage percentage surfaced directly on the merge request page, right? So that's easily shown here without having to dive into perhaps our code coverage unit test and look at the build log. We also directly show you the impact of this change on code quality. And so what that means is we actually take the JSON report from code climate for this branch, and we compare it to the JSON report for your target branch, in this case master, and look for the differences or the delta. And so rather than making a reviewer dive in, take a look at the static analysis, we simply present with you the most relevant information for this merge, which is that this is the change. In this case, we have a pretty mundane error here, someone left behind to fix me from a previous merge, and you can see we of course did fix this. But in many cases, these static analysis reports can be quite long, and going through them can be somewhat tedious. And so it's really helpful here to have some intelligence to actually compare, right? Because the number of findings just might not be relevant for this particular change. And this gives you that delta look, from essentially the impact on code quality with this merge, which makes reviewers' lives a lot easier. Now, the other thing to note here is that we also noted that this is going to close or address our JIRA issue number 11. And so similar to what you saw earlier with our integrated issue boards, we also have an integrated with JIRA which performs the same behavior. So let's go ahead and merge this issue. We can go ahead and look at the code changes here. In this case, you can see, sure enough, we clean up the fix me. So that's great. So let's go ahead and merge. Our pipeline passed. And in a couple seconds, this will kick off a new pipeline. And also, we'll go ahead and close our JIRA issue. So let's take a look at what that looks like. So here's our JIRA issue. You can see it's currently done. And we've also gone ahead and linked it with our merge request, right? So our merge request went in, GitLab said, hey, you know what? This issue is related to this merge request. And oh, by the way, this commit just closed this issue or addressed this issue, and we're done. Really nice integration there to have the same level of integration that our internal issue boards and issue services have along with JIRA. So now let's go ahead and take a look at our pipeline. All right, so you can see this actually went quite quickly here. So our build has already passed, and you can see we're now went ahead and utilized Maven to build our library. We then have our test stage. Now, unfortunately, I took too long talking about JIRA here, but these jobs do run in parallel, and we'll see that again in a little bit later in the demonstration here. So code climate will run, and so will unit test, and they'll run in parallel as long as you have a runner or available runners capable of doing so. So let's take a look at our unit test. And you can see here, sure enough, here is our code coverage report. And here are our artifacts that we just also persisted, so 31 files. And if you look at the right-hand pane, you see the same information also shown. So 85% test coverage, again, extracted from the build log, and also available are our job artifacts. And you can, of course, work with them here, download or browse, or of course, they're available for future jobs as well. Now let's also take a look at our code climate stage. And so here you can see us pulling down the code climate Docker file. We then kick it off, then extract the JSON report back out, and you have that result here. This is the most recent pipeline. That was the earlier pipeline. This is the master pipeline. Apologies for that. So here, this pipeline just finished as you saw the notification pop by, and you would have seen these executing down through the pathway there. And again, we'll see this in just a little bit here as well. Next up is our Java docs, and then after that passes would be a release publish. And again, this build log is live, and so as the build completes, you'll get live updates in your build log that will show you the progress in real time. And if you scroll up to the top here, you can see, sure enough, here is our package cloud token we're using, and again, that is passing, although you can't actually see it in the build log, and you can't see it, of course, either in the repository. Now, we have finished our deploys, as you can see here, and have triggered our downstream project, which is now running. But also, you probably saw the notifications for our new pipeline here. So what popped up earlier was our Slack notification, as well as a GitLab notification that our pipeline has finished. And also, of course, if we dive into our Slack channel, you can see that we have a successful pipeline here completed in just about 1 minute and 50 seconds to complete. And again, this is leveraging that Slack integration you saw earlier. Let's take a look at our downstream pipeline. And you can see we're just about wrapped up, deploying into production just about right now. And let's take a look. So we'll go ahead and build our Java package in this case. We'll then go through and we will test it with our integrated testing. And then in this case, also build our war file. And then deploy it to our container registry. And then also at this point in time, create our production deployment, leveraging that container that we just built a couple seconds ago. And so this has just finished here. If we hop into our environments tab, we can see that we now have one pod running with our environment, which is fantastic. We can go ahead, of course, and do all intended other behavior. Take a look at our deployments. You can see we just had it. So this will deploy here. And that's great, right? So all the same behavior you can see saw earlier with our previous demonstration, you can do here as well. You can also take a look at our container registry. And so this is, again, the integrated registry that we have as part of GitLab. And you can see some helpful information here, like how to log in and how to push. But also provided is a look at the containers that are included here. And so you can see this is our image that we have, our Java front-end image, and we have the following tags. So our master branch just got pushed, which is great. You can see that information here along with the lesson was updated and the size. Then I also do some manual pruning here if you want to as well. We also have a tool available to do this in bulk if you have a larger set of images you want to perhaps clean up or trim some of the older images. So let's return back to our library here and make some further changes. So that was a successful merge. Everything passed. That was great. Let's go ahead and see if we can improve some other areas of our library. And again, similar to earlier, this is not the most complicated Java project in history, but the complicated aspect of the source code isn't the intent here. It's more of the workflows and how to work with GitLab CI. So you can see we simply say hello and bye to our users, but simply bye is a little perhaps too abrupt. Let's say goodbye to be a little more polite. We'll make a new branch, a new merge request, commit our changes, and we'll have our new pipeline and new merge request running here in just a second. We'll submit a merge request, and here we go. All right, so while our build completes, you can see we also have a new button here, which is merge when pipeline succeeds. What this means is that I'm a reviewer and our pipelines are perhaps taking some time or they're queued, I can go ahead, review the changes, say those look good, hit the merge when pipeline succeeds button, and as long as CI passes, it'll go ahead and continue to merge. If it fails, the developer will have to go back in, look into why, make the changes, and then resubmit that to me for approval again. Now, I mentioned earlier how these run in parallel. You can see them doing so here as well. Let's dive into our unit tests. You can see we're going ahead and picking up the required Maven information, and that has just finished. And unfortunately, our unit tests have failed. So we changed our greeting but it looks like we forgot to update our associated tests. And so our unit tests have failed. And you can see here we're getting notifications from Slack and from GitLab that, of course, we have failures. The other thing to note here is that you can see the favicons have also indicated failures here as well. So not just do you get notifications in Slack, but also we give you a corresponding failure in the browser tabs. Compare that to our successful merge and pipeline you saw earlier here with the green check mark. So that's unfortunate. We can hop back into our pipeline, get the overall look here, and of course, this failed, although CodeClimate succeeded, and we of course got again a bevy of notifications here. So here of course is Slack saying that this failed, and we also got an email here as well to indicate that our pipeline has failed. And so by default, GitLab will email you for pipeline failures. You of course can change that to also get emails on successes, although that tends to be relatively chatty depending on how many changes you make. So again, a wealth of options here to convey a failed pipeline. The other area where we make this easy to continue on and perhaps follow up is we have another option in our failed job to create a new issue. So for example, you can see this button here because this was a failed job, perhaps it's a flaky test. And we want to make sure it was easy to capture this information, to file a new issue, and to, again, improve the follow-up that this might get tracked. And so you can simply click here. We'll go ahead, open a new issue, attach the build log, and make it easy to go ahead and, again, capture this error. You may have also seen that we created a new to-do here. And in this case, we also added it to your list to say, hey, you know what? This pipeline failed. You should go ahead and take a look at it and see what happened. So again, a number of ways to let you know a failure and also to help improve the follow-up on these failures, whether it's notification or making it easy to create issues, again, for perhaps some flapping tests. So that's a quick tour of the integrations and the power of GitLab CI, right? So we went through and we showed how you can integrate with any Git repository. You can tie into a variety of other Agile planning services. It has easy integration with a variety of other tools. In this case, we showed Maven, CodeClimate, and JUnit tests. But again, because it's based on bash scripting, anything you can bash, you can also script as well. And so pretty much, like as you leverage the CLI on your laptop, you can take those same commands, apply them here, and be able to work with CI jobs in the same way. We also have ways to kind of, at a broader level, take a look at CI as a whole, right? So in this case, we are taking a look at kind of me as a developer, but if I'm more of a administrator of a project or perhaps someone who wants to take a look at how the pipelines are running, we have a wealth of information as well to do that. So you can see here, we have our pipeline information for all of our pipelines historically as well. So here, of course, is our latest 2 pipelines that we ran just today. You can see we had a number of other pipelines run here as well. And all this information, the build status, the build logs, is all persisted. The artifacts are also persisted, provided they haven't expired, which you can configure. And again, so all this information is available for later review. We also provide a number of statistics on your CI status as well. So this is our public monitoring dashboard for GitLab, GitLab.com. And you can see some of the statistics that we make available through our runner and through GitLab itself. And these are based on Prometheus. And so in this case, you can see, get a live look at, again, what's available. So you can see how many runners you have currently taking jobs, how many jobs you have in certain stages, and how many jobs you have running as a whole here. And so in this case, you can see we've got almost 800 jobs running on GitLab.com, which is perhaps a little low for us on GitLab.com. Typically, we see some traffic over 1,000. But again, some insights here on runner health, pipeline health at the whole sort of instance level for all of your runners. And so this can help to take a look at sort of how things are performing on your instance. And so that's monitoring of the GitLab pipelines and the GitLab runners. And we also, of course, again, have a wealth of information that you kind of saw earlier on analytics and other intelligence, right? We showed you earlier the static analysis that we have available for calculating the difference between the code you're trying to merge into master and the analysis of the code in master and presenting that delta to you directly here on that page. We also obviously can surface the code coverage results, the cycle analytics for your team, and also the application performance metrics as well to get a sense of how your code is behaving in production once it's been deployed. And so that's a pretty high-level view of GitLab CI for a developer and the developer flow. The next place we want to go to is to show you a little bit more information on our GitLab runner. So our runner is obviously a large part of what makes GitLab CI work because it actually is essentially the worker bee for GitLab CI. So if we pop over here, we can take a look at our pipeline settings, and you can see that we have a couple runners available to us. So we have our share runner, which you can see here. This is running in Kubernetes and provides that auto scaling behavior that is so helpful. So in this case, if you run one in Kubernetes or on Docker machine, this runner will actually automatically kick off new runners as needed to service the pipeline or the queue that is pending for CI. Now you also have complete control over runners for your project here as well. So for example, if I needed to perhaps run some iOS tests or some OS 10 tests, I can simply connect my own runner to my project. This is, again, helpful if you have some specific needs, maybe a mainframe which you have to do some testing on. But it also is great if in the event that your administrator does not provide a shared pool of runners as we see here, you can simply connect your own. And it's really, really easy. Now, let's take a look at how this is done here. Now, I've already gone ahead and downloaded our runner installation and installed it on my machine. It's really simple. It's a Go project, so it's a single binary. Simply download it, throw it in your path, mark it executable, and you're on your way. And from there, you can then simply register it with your instance. Now, to do that, you type in GitLab runner register. You pass in the URL to your instance. You pass in the token. And you can then give it a name, like my laptop or OS 10 laptop 10 to 12, as you saw earlier. And then you have the opportunity to specify some tags. And this is where you can then inform or describe what special properties this runner has. Right. So in this case, you can see, again, we might say it as OS 10. We might say we have the iOS 10.3 SDK on this machine. We might say we have an iPhone 6 attached via USB. Whatever you have to do to specify the uniqueness or special properties of this, if there are any, you can do so here. You then have the option of saying whether or not this runner should pick up sort of generic CI jobs. We'll say false. And we're then registered. And we can now choose the executor or the mode we want this runner to behave in. And in this case, you have a couple options. The simplest of which is shell, which means that the runner will simply take the script that you defined in the YAML file and then just run that under the current user, under the current machine that you have here. Building on that is getting into some of our virtualization components, whether it's images or containers, with things like our VirtualBox integration, parallels, and of course also Docker. In this sense, you can leverage that specification at the top of like what Docker container you want to use, and then we'll actually spin that up, run the script in there, and then tear it down and clean it up after we're done. And this can be really nice because developers can bring their own dependencies and they can manage their own sort of containers in a very, very clean way. And it works really great with the shared instances, but also, of course, any specific runners you want to have as well. And then we have sort of the more advanced versions, which is Docker Machine and Kubernetes, where you get that same container behavior, but the runners will automatically scale themselves as needed to process your pipeline. In this case, we'll go ahead and use shell, and that's it. And we can then simply type in GitLab runner start, and our runner is now ready to go. So that's how easy it is to go ahead and install the runner and get started. You saw earlier how easy it was to configure the CI YAML file as well with our templates. And so really, you can see an example here of the self-service nature of GitLab, and how the fact you don't depend upon your administrator perhaps to go ahead and provision maybe some iOS or some OS 10 devices for your iOS testing, rather than asking them to go ahead and buy a bunch of Mac Minis, put the PO in, put them in your data center, care and feed them. You can simply take a laptop from the cupboard, off the shelf, an old perhaps someone's old machine, power it on, and go ahead and install a runner and be on your way in just a few minutes. So that's pretty cool and powerful there, in the sense that we try to make sure developers are empowered and can take care of their needs as they need to. And of course, you also have flexibility with the sense that you can bash and script anything. And then also the scalability here with getting up to 800, over 1,000 parallel jobs, as you see on GitLab.com. So with that, we'll go ahead and take some questions. I think we have a couple here, perhaps in chat. Let's take a look. Looks like we have, let's see here, we scroll up to the top. All right, so so GitLab CI also works with non-websites. So certainly, you can do some Xcode, iOS, for example, testing. You can simply run the Xcode commands in your scripting file and execute the, for example, iOS simulator, have it run your tests and do it that way. Some of these services do lend themselves to support for backend services like review applications, like the environments, but certainly, it's not limited to those use cases. And again, you can do Android testing. We have people doing deep learning on ARM with the GitLab runner, for example. So not really limited for again, backend type services. We have a wealth of templates, and you can take a look at some of those here. So we have, in this case, if I hop in and add a new file and then pick one of our templates here, you can see the variety of templates we have available. People are asking about PHP. And so here you can see we have some options for sort of a starter script, perhaps, for PHP and how you might do that. This looks like it's leveraging sort of PHP, the Docker image, as well as depending upon the MySQL image as well. And you can see some of the examples of how to get started here, as well as kick off some unit tests. A couple other questions. Looks like someone has already pointed out the PHP README examples, which is great. Thank you for that. Geo integration is awesome, so appreciate that comment there. We certainly have a lot of customers who use it. An example of how to set up WordPress on GitLab with MySQL. I don't think we have a WordPress option here, so that's an interesting one. I would think it's been a PHP type example, but point taken. Appreciate that feedback, and we'll pass it to the team. And another question on what parts of CI/CD are not available in CE. So all the basic functionality is there. A couple aspects that I showed you earlier are not there, which is the deploy boards, where we showed you kind of the live look at the Canary versus production and how each pod is running. So that functionality is part of our EE product, and our cross-project pipelines. The visualization aspect is also part of our EE product, but you can certainly trigger webhooks without that as well. You just won't get the nice visualization components in the pipeline chart. Okay, another question on Docker Swarm and Mesos deployments. We don't have the same kind of Kubernetes executor, if you will, for Mesos, but certainly they all have CLI utilities that are associated with them, and so you can absolutely script those as well. And so, for example, AWS works the same way. You can download the AWS CLI, kick off workloads in AWS. Same thing goes there for Mesos and other ones. Actually, now that I say that, we actually do have a Mesos runner that's available to help that as well. And so check that out. I think it's right here, in fact. So apologize for not mentioning that earlier, but we absolutely do have a GitLab runner service that's available on DCOS to help out in that sense. Another question on group and shared secrets. So that's something that we're working on. So I didn't mention it here, but as you saw, we do have, all right, I didn't show it here actually, but you do the option with 9.0 of GitLab to have subgroups. And so that is brand new in 9.0. And so I can go ahead and create n numbers of these subgroups. And I think it's up to like 20 plus deep of them. And now that we have this sort of baseline foundational aspect of our grouping system, we're now going through and adding a lot of our project settings that you can set at the project level, and adding that and bubbling it up into the grouping level as well. And so you'll see a lot more of the, again, project level settings make their way into group settings as well, so they can help to cascade down and provide some defaults. So I think that's all the questions. We'll give a minute or two more for more questions. And if not, we'll wrap it up here. Thanks everyone for watching and for your feedback and questions. All right, well, thanks everyone for your time. Hope you enjoyed our look at CI here. And pay attention to our, again, social media channels here for future updates. And hope to see you all soon and talk to you some more. Thanks.